Mrs. Questel here. I thought it would be interesting to teach a math lesson using my phone as a camera and to set up and show you how to do two different ways of long division. So let's start with the conventional method, which is a series of steps. And let's just say, for example, that I have 792 marbles and I want to give those marbles out to 6 people. And my question would be, how many marbles would each person get? And would there be any left over? So, in order to do that, we have set up a dividend, 792, a divisor, which is 6, and the answer is going to be what we call the quotient. So, in order to do this, there are a series of steps. Divide, multiply, subtract, check, bring down. You can come up with any method of mnemonic device to help you remember the steps, but I put them here for you so that we can go through each step as we go through the division process. Okay, let's take our 6. And the first question you're going to ask yourself is, can 6 go into 7? Can I divide 6 into 7? And the answer would be yes, one time. So in order for me to know what my answer might look like, if I can put 6 into 7 one time, I'm going to put a line above each digit, which will note how many numbers my answer is going to have. So I cannot have more than 3 digits in my answer. Of course, if I had a remainder, it would be not part of these digits, but it would be the leftover section. Okay, 6 can go into 7 one time. So let's multiply 6 times 1 equals 6. And you might wonder, well, what do I do with the 1 and what do I do with the 6? Well, I put the 1 up here because I'm actually multiplying 6 times 1. And I put the answer of 6 underneath the 7. And then my next step would be to subtract. Subtract out the 6. 7 minus 6 is 1. And now I have to check. What am I checking for? I'm checking to see that this number 1 is less than the divisor. If it isn't, then we did something wrong. But if it is, we can move on to the next step, which is to bring down. I like to line up all my numbers evenly, so I draw an arrow down from the 9 so that my numbers all line up, so I don't get confused with what I'm bringing down. Now that I brought down, I can go back up and start again and ask myself a new question. Can 6 go into 19? How many times? Well, oftentimes there are instances where you have to go through multiple multiplication numbers to get the answer. 12 would be too small. But 6 times 3 equals 18 sounds about right, because it's 18 is as close as I can get to 19 without going over. And then I say 6 times 3, the 3 goes on the top, multiplied. Now let's subtract. 19 minus 18 is 1. Trying not to move the page in the camera. And I need to check. What am I checking? To make sure that the 1 is less than the divisor 6. If it is, I can bring down any other number. And the next number is 2. I use an arrow, you can see, to line up my numbers nice and even. And then I ask myself again, go back up to the top. Can 6 go into 12? Yes, it can. Check. How many times? 2. 6 times 2 equals 12. Multiplied. Subtract. What are we subtracting? 12 minus 12. Where did I get the 12 from? I'm sorry for moving the paper. I got the 12 from multiplying 6 times 2. 6 times 2. Subtract. Check. 0 is less than 6. 0 happens to be the end of the problem because there is no remainder and there's nothing left to bring down. So my answer is 132. What did I ask? I asked how many marbles would each person get? Each person would get 132 marbles. Let's check our answer to make sure it's correct. In order to check your answer, you multiply the quotient by the divisor. So 6 times 2 is 12. Carry the 1. Sorry for moving the paper. 6 times 3 is 18 plus 1 is 19. Bring the 1 up here. 6 times 1 is 6 plus 1 is 7. And the answer, 792, matches my original dividend. So I know that I have 132 marbles to give each person. Okay? That's the long division method using divide, multiply, subtract, check, bring down. Let's take a look at the same problem. Let me set it up for you. 792 divided by 6. And let's use something called the box method. Okay. Why is it called the box method? Because we're going to take the 792 and we're going to use each place value as a box. And we're going to write 792 in expanded form. You know how to do that. 7 is 700. 9 is in the tens column, so that must be 90. And 2 is 2 ones. What do we do with the divisor? We're going to put it outside the box. Okay, so I'm going to start and ask the question again. Can 6 go into 700? Only 700 is a large number, so I'm going to erase the zeros for a minute, or cover them, and ask myself, can 6 go into 7? Sure, it can go in one time. So I take 6 into 7 is one time, and I'm going to bring down the zeros. Okay, and if you multiply 6 times 100, I'll do it over to the side, you get 600. So I'm going to take 700 and subtract 600. Don't be confused that the hundreds are different. This 100 gets moved and brought over into the next box, or the tens column. And I'm going to go through the same process. Ask myself, can 6 go into 19? Yes, 3 times, plus the 0 on the end, which is really 6 times 30. 6 times 30 is 180. The difference between 190 and 80 is 10, so I'm going to bring that over into the next box. And I start again. Can 6 go into 12? Well, I know that 6 times 2 is 12. And it looks like I have finished all my division steps. So what do I do to get my answer? I then add each number that was in the box. 100 plus 30 plus 2. Adding all the numbers that were in the boxes, I get 132. That would be my answer. And again, to check your answer, you multiply. Six times 2 is 12. 6 times 3 is 18, plus the 1 is 19. 6 times 1 is 6, plus the 1 is 7. My answer equals my dividend, so I know that my division process is correct. And that is the box method. Okay, and there you have it. Now let's practice.